Empirical gas law, specifically about a graph of empirical gas law. What are the empirical gas law? What do you mean by empirical? Empirical means experimental. So these are empirical gas laws: Boyle's law, Charles' law, Avogadro's law, and Gay-Lussac's law. For introduction, you know that Boyle's law states that at constant temperature and fixed amount of the gas, pressure of the gas is directly proportional to 1 by V, or pressure of the gas is inversely proportional to V. And Charles' law, volume of the gas at fixed amount and constant pressure is directly proportional to temperature. And Avogadro's law, volume of the gas is directly proportional to amount of the gas at a constant temperature and pressure, or at constant temperature and pressure, volume of the gas is directly proportional to N. And Gay-Lussac's law, pressure is directly proportional to temperature at a fixed amount and at a constant volume. So these gas laws are you already studied in your high school class syllabus. Okay, I am going to discuss basically mainly about the graph. Okay, so let us discuss more detail about this gas law. Boyle's law में two type of gas. The graphs are there. The volume pressure versus 1 by V graph, and pressure versus volume graph. Okay, mathematically the Boyle's law can be represented: P is directly proportional to 1 by V, or at fixed amount and the constant temperature, or P is equal to K1 into 1 by V, or PV is equal to K, and P1 V1 is equal to P2 V2. Okay, so let me again discuss this graph with the help of these two equations. So, P versus 1 by V. This is a straight line graph. That is, this is a type of y is equal to mx, or m is slope, that is k. So that is straight line passing through the origin. We can say that this is a graph at constant temperature and fixed amount. Okay. So say, let me discuss in detail, say T1, T2, N, and T3, N. Graph plotted at constant temperature is called isotherm. So these are different isotherm. This is one isotherm, this is another isotherm, this is another isotherm. So graph plotted at constant temperature is called isotherm. So let me ask one question with respect to this. T1 is greater than T2 greater than T3, or T1 less than T2 less than T3, say A and B. A or B is correct with respect to this graph. This is very simple. This can be easily explained. So, you know that P is equal to K1 into 1 by V. Again, for explanation of this graph, very simple way to explain about this graph, it is easy, you know that PV is equal to nRT. This is universal gas loss equation. This is also you know about this equation. Okay. So you take according to that you rearrange this equation. So you can say that P is equal to 1 by V nRT. So this is your M, that is equal to K1. Okay. That is K1 is equal to nRT. What do you mean by this? Slope is equal to nRT. That is, slope is directly proportional to T. So in this case, where is the maximum slope? This is 0 slope, 1 slope maximum. That is, this is with respect to these three, you can say that this is having the highest slope. Okay, so this is drawn at T3, this is drawn at T2, this is drawn at T1. So which one will be the highest? So slope is directly proportional to T, that is T3 is greater. So B is the characteristic. Okay, slope is lower here, highest slope is here. So this is the characteristic. Now let us discuss about this graph. So you know that PV is equal to K1, right? That is, this is a xy is equal to constant. Xy is equal to constant is for hyperbola. Okay, so pressure versus 1 by volume will be a hyperbola. Again, suppose this is at T1, this is at T2, this is at T3. Fixed amount N1, N, N, and N. That is at fixed amount, different temperature. So this is a xy is equal to constant, that is hyperbolic graph. So you just remember for the sake right now, this is eccentricity, it is related to eccentricity, and eccentricity related to distance between this and this. This is having the highest eccentricity and T3 will be greater. Okay, so T3 is greater than T2 and T1. This type of two graphs are normally asked in the entrance examination. So this is all about the Boyle's law graph. Now let us discuss about the Charles law. What is Charles law? What is Charles law? Volume is directly proportional to temperature at a fixed amount and a constant pressure. It states that at a fixed amount and constant pressure, volume of the gas is directly proportional to temperature. Or you can say like that, V is equal to K2 into T. Okay, this can be represented also, T1 is equal to K2, or T1 by T1 is equal to V2 by 2. These are different mathematical representation of Charles law. Okay, now let us discuss about the graph. So volume versus temperature graph. Okay. Here, what is interestingly found, the volume versus temperature graph, So suppose these are different experimental condition, and this is say P1, P2 and P3. It is interestingly found that at a zero volume the temperature is, that is in the all the graph at meter extrapolated gives a value minus 273.15. What is it called? It is called absolute 0 degree. That is, this is 0 Kelvin. This is called a Kelvin 0. That is, in this temperature no gas exists. Okay, no gas exists at this temperature. Volume is 0. That is, again let me give some detail about the Kelvin scale temperature. Kelvin scale temperature is equal to T degree Celsius plus 273.15. This is degree centigrade. What do you mean by degree centigrade? Degree centigrade is related with water. At 0 degree water melt, and at 100 degree water boil. So these temperature are divided into 100, and the one division is called 1 degree centigrade. So this is related with water. Okay. So it is easily you can calculate if you have given degree centigrade to Kelvin and Kelvin's temperature to degree centigrade plus this question. So let us discuss about this graph. So again you take that it is equal to nRT. Okay, remember that one. So V is equal to the K into T. What is the K? Say K2. K2 is equal to what? K2 is equal to nR divided by P. Right? K2 is equal to nR divided by P. So this is again a graph like y is equal to mx. Okay. That is a straight line. But temperature, if you are taking T in the Kelvin scale, this is like that. This you have to start from here. But if you are taking the degree centigrade, it meet at the point temperature. T will be T0 plus 127.3. Okay. So this is you know that. What about I am specifically interested into the graph. So what about, let me ask again, A P1 is greater than P2 greater than P3, or B P1 is less than P2 less than P3, which is correct? It will be the correct. Where is the slope maximum? Slope maximum. This is the slope maximum, slope minimum here, slope maximum here. So slope is inversely proportional to pressure. Slope is inversely proportional to pressure. So you can say that maximum slope, minimum pressure. So maximum slope here, and minimum pressure. That is P3 is very less than P1. So A is the correct. Okay. Next, this is all about Charles law. Okay. So if you are interested in here about the graph, and I am discussing only about the graph, there are later things discussing later. Next is Avogadro's law. What is the Avogadro's law? Avogadro's law can be explained different way. Volume is directly proportional to amount at a constant temperature and pressure. At a constant temperature and pressure, volume of the gas is directly proportional to amount of the gas. So again I am just giving another definition is also there. Say volume constant, pressure constant, temperature constant, volume constant, temperature constant, pressure constant. Suppose here is H2 and here is O2. So equal volume of the all gases at a constant temperature and pressure contain equal number of molecules or equal amount, equal number of moles. That is also another definition of Avogadro's law. So again here I want to discuss more about the graph. Say volume versus N. Say I am again I just want to discuss about the the graph plotted constant pressure is called isobar. Okay, I forget to discuss about that. That was constant pressure. Here again let me say isobar P1, P2 and P3. Say I am taking constant temperature and temperature. So my question again, P1 greater than P2 greater than P3 or P1 less than P2 less than P3. Sorry, P3 is greater than P2 than P1. Say A and B. Which is correct? How you explain about this graph? So these are different isobar as well as isotherm. Okay, at constant pressure and temperature graph. So here I kept everywhere temperature constant and defined P1, P2, P3. My question is P1 is greater than P2 or P2. So in this case also you can explain with the help of you know that V is equal to RT by P in N. If you rearrange P is equal to nRT, that is RT by P in N. That is, this is K3, that is slope, that is